Hi guys, welcome back to my channel. In this video, we are going to look at the topic types and methods of data transmission. First, let's look at the meaning of data packet. Now, when you send data over the internet, let's say an email or a file, that data doesn't travel all at once. The data is broken down into small units called data packet, or is sometimes called datagrams. For example, imagine this is the data you are sending. So these data will be broken down into smaller parts, and each part is called data packet. So each part will be sent separately to its destination, and when it gets to the destination, these data will be put back together. So that is data packet. Now, in each data packet, there are three key parts. Imagine I'm sending these data and it is broken down into these two data packets. So in each data packet, we have these three key items that will be in this data packet. So we have the header, the payload, and the trailer. Now let's look at the meaning of each one. In the packet header, In the packet header, we would have the IP address of the sender. We would have the IP address of the receiver so that the router knows which destination the data is going to. Then we'll have the sequence number of the packet so as to allow for reassembling of the data. Remember, the data is sent separately, so when it gets to the destination, it might not arrive in the correct order. So the sequence number will be used to reassemble the data back into the correct order. And then we have the size of the data packet. So the size of the data packet is also used to check for error to ensure that the correct data arrived. Then we have the payload. So in the payload, that's where we have the actual data that is being sent. The actual data that is being sent to the destination, that is the data that will be stored in the payload. Lastly, we have the packet trailer. So in the packet trailer, we will have some way of identifying that this is the end of the packet. Also, we will have an error checking method, which is cyclic redundancy check. So this error checking method is used to ensure that the data that arrives has no error. The data that arrives has no error. And how does this error checking method works? So the sending computer will add up all the 1 bits in the payload. Let's say data is this. So the sending computer will add up all the 1 bits in the data, and it will store it as a X value in the trailer before it is being sent. So once the data arrives at the receiver end, the computer will recalculate the number of 1 bits in the payload. After recalculating, then the computer compares, it checks the value against the one that is sent with in the trailer. So if the two values match, then that means there's no transmission error. Otherwise, the packet needs to be resent. So these are the three items in the data packet. Now let's look at packet switching. So remember, we said instead of sending one large file at a time, this file is broken down into data packets, and each data packet travels through various routers and nodes to the destination. Now, this method of breaking down data into data packets is called packet switching. So how does this work? Now, imagine this is computer A and data needs to be sent to computer B. So each packet can be sent independently from the starting point to the ending point. At the destination, the packet will need to be reassembled. Remember, the data will be splitted, it will be broken down, and the data might not arrive in the correct order. So when it gets to the destination, these data will be reassembled so that it's in the correct order. Now, at each stage in the transmission, there are nodes. Okay, these are nodes that contains router. Okay, in each node there is router. And each router will determine which route the packet needs to take. For example, this router can determine that the packet needs to take this route or this route. So in order to reach its destination. So that is how packet switching works. Now let's look at some of the benefits and drawbacks of packet switching. The first one says there is no need to tie up a single line communication. So it means that packets use any free route. The data packet does not need to wait, for one packet to go through a line and then use the line. No. The data packet can use any route that is available. Then a high data transmission rate is possible. Data can travel faster using the best available and shortest path to its destination. It is easy to expand packet usage. So we can add more users. More users can be added without requiring any additional setup or much setup. Now let's look at the drawbacks. Packets can be lost and need to be resent. So it can be due to interference. Some packets may be lost, and when packets are lost, it has to be resent. The method is more prone to errors with real-time streaming. So this method is not ideal for live streaming because there can be delays and errors can affect the real-time applications. There is delay at the destination whilst the packets are being reordered. Remember that data packets are sent differently, they follow different route and may arrive out of order. So when it arrives out of order, the data packet needs to be sorted. It needs to be reordered. Now let's look at data transmission. So data transmission refers to sending of data from one device to another. And data can be transmitted either over a short distance or long distance. There are three factors that needs to be considered when data is being transmitted. We need to consider the direction of the data. For example, can data be transmitted in one direction only or in both directions? We need to consider the method of transmission. For example, how many bits can be sent at the same time? How many bits can be sent at the same time? Then, how will data be synchronized? So we need to ensure that the received data is in correct order. So in these factors are what we considered as communication protocol. Now, transmission modes. So the transmission modes, we have three types: simplex, half duplex, and full duplex. So let's look at each one by one. The first one we have is simplex data transmission. So what does this mean? It means that data can only be sent in one direction only. Data can only be sent in one direction only. For example, when we are sending data from the computer to the printer, The data can be sent from the computer to the printer, not from the printer to the computer. So the data can only go in one direction. Data cannot be received in the other direction. So that is simplex. Then we have half duplex. So this occurs when data is sent both direction but not at the same time. It means that these two devices can send data to one another. Both can send data to one another, but it cannot be at the same time. When device A is sending data to device B, there needs to be a pause, meaning that device B cannot send to device A at the same time. So, an example would be a walkie-talkie, where a message can be sent in one direction only at a time, but the message can be sent and received on both devices. Now, let's look at full duplex transmission. Now, what does this mean? It means that data can be sent in both direction and at the same time. In both direction and at the same time. For example, we have two phone devices, telephone. So, receiving and sending. Okay? So, two devices can be communicating with one another and the data can be sent at the same time. When you're on call with your friend, you can hear them, they can hear you, you can speak, they can speak at the same time, and the data will be delivered in both directions at the same time, simultaneously. So that is full duplex. Now let's look at the types of data transmission. So we have serial data transmission. So this occurs when data is sent one bit at a time over a single channel. One bit at a time over a single channel. So imagine we want to send this data. Now this data has to go bit by bit, one after the other, one after the other, over the same wire, the same channel. So this is serial data transmission. Then parallel data transmission. This means that several bits of data are sent down several channels all at the same time. So unlike serial that requires the data to be sent bit by bit, but for parallel, all the data can be sent at the same time over several wires. So that is parallel data transmission. Now let's look at the difference between serial and parallel in form of a table. So we say the first one, less risk of external interference than with parallel due to fewer wires. So with just one data wire, there's less chance for noise or interference from other signals, so making it more stable. Then more reliable transmission over a long distance. So because it sends one bit at a time, it avoids timing issues, making it an ideal for long cables and connections across distances. Then transmitted bits won't have the risk of being skewed. So in serial transmission, bits are sent one after the other, so they remain in the correct order when it is being sent. Then used to send data over long distances. So it's the preferred method for long distance communication, like over the internet cables or satellite. Less expensive due to fewer hardware required. So since it uses only one channel, only one wire, It needs less physical infrastructure and it's more cheaper to implement. Now let's look at parallel. So we say that parallel is faster rate of data transmission than serial. So multiple bits are sent at the same time, which makes the transfer quicker over short distances. And then we say that it works well over short distances. So it is ideal when devices are close together, like inside a computer or between chips or on a circuit board. So it works well over a short distance. Then, since several channels are used to transmit data, the bits can arrive out of synchronization. So each wire may carry data at slightly different speed, and this can cause bits to arrive at different times, especially over long distances. So this is known as skewed. Then if data is time sensitive, parallel is the most appropriate. So in short distance situation where timing is very critical, parallel can transmit multiple pieces of data at once, and this makes it faster and suitable for real-time tasks. Then expensive require more hardware. Since it needs multiple wires, it is more complex and costly to set up compared to serial transmission. Okay, now let's look at USB. So USB is also a form of serial data transmission, and it is the most common type of input and output port that you can find on any computer device now. So a USB allows both half duplex transmission and full duplex data transmission. So in a USB cable, it consists of four wires. Okay, the red, the white, the green, and the black. So the two wires for power is the red and black. The red and black is used to transmit power supply. Is used to transmit power, while the white and the green are used for data transmission. So let's look at USB-C. So USB-C is the latest connector that is used nowadays in laptops, tablets, and it has 24-pin connector, which means that it can fit into a USB port in both ways. Okay, it can fit into USB port in both ways. So a USB-C is they are smaller, they are thinner, and they are more powerful. So it can even deliver about 4K video. Okay, it can support 4K video and it can charge full size devices. You can use a USB-C to charge your devices. So that is all for USB-C. Now let's look at the benefits and drawbacks of USB system. So the first one, we have devices plugged into the computer are automatically detected. It means that as soon as you connect a USB device, the computer recognizes it without needing any extra software or any driver. Then it can support different data transmission rate. So USB supports various speed when it comes to data transmission. No need for external power source since cable supplies 5 voltage power. So a USB cable can provide um, about 5 voltage power to small devices like your keyboard, your webcams. So which means that you don't need a separate power supply for your device. Then it is relatively easy to add more USB ports if necessary, by using USB hubs. So if your computer doesn't have enough USB ports, you can plug in a USB hub to expand and connect more devices easily. USB is backward compatible. The newer USB ports can still work with the older USB devices. So, but for example, a USB 3.0 can read a USB 2.0 flash drive. It will just operate at a slower speed. Then the drawbacks. So we say that standard USB only supports a maximum cable length of 5 meters. So USB cable can be too long. If they are over 5 meters, the signal may become weak and causing issues in data transmission. Then we say that data transmission speed is slow. So although USB is widely used, it can be slower compared to other modern alternatives. So that is one of the drawbacks. And lastly, even though USB is backward compatible, very early USB standards may not always be supported by the latest computer. So there are some very old USB devices that might not work on modern computers, even though the newer USB versions generally support older ones. So these are the benefits and drawbacks of USB system. So that's all for this lesson. Please do not forget to like, share, and subscribe.